Hi, this is Josh again and tutoring calculus level 1. For this exercise, what we want is we want to take a function and have a floating point that's going along the function curve, and then graph a tangent line so you can visually see how the slope of the curve is changing as it goes down from this domain, -20 to 20. So here I'm using the function f of x equals 10 sine x upon x. And to create the floating point that's tracking the function for xy, I use the point a comma f of a being a slider point here. If I hit play on the graph, you can see this blue dot going down the function string from -20 to 20. The next thing I want to do is I want to create the tangent line to this blue dot along the curve. Focusing on that blue dot, I'm going to put a work circle around it here. Again, tracking the point using the circle equation, x minus a squared plus y offset by f of a squared equals 4. I chose the radius to be 2 because it looks much nicer. If the radius is 1, it's a little bit small for the exercise here. And so I scaled it up to a radius of 2. So you can see that the black circle is tracking around with the center point, a comma f of a, and it has a radius of 2. The next thing I would want to do is create a line for this function. And here I'm using point slope form. So I have this equation down here, y equals, the slope is the slope of the tangent, f prime of a, times x offset by a plus f of a. So that will create a line that intersects, that has a slope of f prime of a, but that intersects at the point a comma f of a. You can see that this purple line is changing as the slope goes positive and negative as it travels down the function string. But I don't like the purple line because it's visually distracting to see it go from one end of the screen to the other. So to truncate that so that it looks, so that it's always the same length, I have to use the following domain restriction that you can see down below. This domain restriction will take the tangent line, but shorten it so that it is in the circle as a diameter from end to end. Let's look quickly at how I use the work circle. How I use the work circle here and the x and y components to find this domain restriction. So focusing now on using the unit circle and reference triangles, what I do here is for the first derivative, since it's f prime of x, I represent that as delta y over delta x as f prime of x over 1. Then using the Pythagorean theorem, finding the hypotenuse of this reference triangle would be 1 squared plus f prime of x squared here equals the hypotenuse squared. Taking the square root, the hypotenuse is precisely the square root of 1 plus f prime of x squared. So this center point is a comma f of a. I want to have the x component here, which is represented as 1. So I need to scale the unit circle here so that the radius is 1. So divide every side by the square root of 1 plus f prime of x squared. Now the hypotenuse is the fixed constant 1, just like my floating point with the black circle around it. Then this side, I would also have to divide by the square root of 1 plus f prime of x squared. Now I have the proper x component. In other words, this unit circle and this reference triangle has been scaled down so that the hypotenuse is now 1. And what I would have to do is take floating point A and add, this is my delta x, 1 over the square root of 1 plus f prime of x squared. Going back to the graph, if I wrote down 1 over 1 the square root of 1 plus f prime of x squared. Yes, that would be correct, but since I changed the radius to 2, what I do for the numerator is I change that also to the radius. So since I chose the radius to be 2, I will write down 2 upon the square root of 1 plus f prime of x squared. And you can see that if this is floating point a comma f of a, that's the left side of the, that's the radius to this point. And then the other domain would go from a to the to this point here. So now, going down the graph, you can see the floating point, and you can see a truncated version of the slope as it nicely goes down from the chosen domain from -20 to 20. If I turn off the circle, which I no longer need because that was just my guide to space out delta x, you get this nice, much more pleasant video showing how the tangent line is changing along the function f of x equals 10 sine x upon x. All right, I hope this video was useful to you in coding and learning your calculus level 1. This was a video presenting a function and a moving point with the tangent line along the domain restriction as given. All right, thanks for watching my video. My name's Josh, and happy studying.